The first interdimensional explorer may not have been human at all. We are about to journey through 30 incredible theories on how the cosmos might have witnessed its inaugural voyage across reality itself. By the end of this, you will possess a new framework for imagining the very nature of existence. We will investigate if the Big Bang was a dimensional rupture and ask if a conscious star could have pierced the veil of spacetime. What single idea about other dimensions truly captivates your imagination? Our journey begins not with a conscious choice, but with a random accident in the chaotic first moments of everything. Picture the newborn universe, a seething, impossibly dense ocean of pure potential. In that frantic sea of energy, reality itself was not yet solid. It was a quantum foam, a bubbling frenzy where particles and forces flickered in and out of existence on a whim. Within this primal chaos, the rules were not yet fixed. The fabric of spacetime was so warped and turbulent that random fluctuations could create temporary tears in reality itself. These were not engineered gateways, but spontaneous, probabilistic bridges to other dimensions. They were like tiny, unstable air bubbles forming in a thick liquid, lasting for only a fleeting fraction of a second before popping back into nothingness. The first interdimensional traveler might have been a single, anonymous subatomic particle. It did not possess intent or a destination. It was simply in the wrong place at the wrong time, or perhaps the right one, quantum tunneling through one of these spontaneous rips purely by chance. One moment it was here, the next it was elsewhere, in a realm governed by a completely different set of physical laws. The implications of this are staggering for our understanding of physics. It suggests that the walls between dimensions are not absolute. They are permeable, and our entire reality might be built upon a foundation of these microscopic crossings. The laws we hold as constant could simply be the most stable arrangement that settled out of an infinite number of possibilities, a quiet neighborhood in a metropolis of wild, untamed realities. That random particle's brief journey might have left a permanent mark on the cosmos. Physicists are now searching for the faintest of echoes from that primordial chaos, a ghostly imprint preserved in the oldest light we can observe. This is the cosmic microwave background, the remnant glow from the Big Bang that fills all of space. It is a snapshot of the universe when it was just 380,000 years old, and within its subtle temperature variations, scientists hunt for anomalies that defy standard explanation. These could be the cosmic scars of an early interdimensional breach. Imagine a single, tiny tear in the fabric of reality occurring just before this light was released. The violent energy release from such an event would have created a unique, localized distortion in the surrounding plasma, a faint cold spot or a strange swirling pattern frozen into the background radiation like a fossil. Detecting such a signal is a monumental challenge. The cosmic microwave background is incredibly uniform, and these potential scars would be immeasurably subtle, hidden within the cosmic noise. Researchers use sophisticated satellites and algorithms to map the sky's temperature with exquisite precision, looking for any pattern that simply should not be there according to our standard models of cosmic inflation. Finding one of these scars would be more than just a new discovery. It would be direct evidence that our universe interacted with something fundamentally other in its infancy. It would mean that the walls between worlds are not just theoretical, but that they have tangible, physical consequences, and that the first journey across them left a permanent signature for us to find, a message from the dawn of time written in the cold of space. This search for a cosmic scar leads to an even more profound possibility. What if the entire universe is the scar? The second theory proposes that the Big Bang was not a beginning from nothing, but a violent transition from somewhere else. It envisions the Big Bang as a dimensional rupture, a cataclysmic tear in the fabric of a pre-existing multiverse. In this view, our cosmos is not a spontaneous creation in an empty void. Instead, it is the result of a catastrophic event in a parent dimension, a reality that existed before our own. This parent cosmos could have had entirely different laws of physics, a different number of spatial dimensions, or a different concept of time itself. Within that foreign reality, an instability grew, perhaps a collision between two membrane-like universes or the collapse of an exotic star. The pressure became so immense that it ripped a hole straight through the dimensional barrier. The first act of interdimensional travel was not a conscious voyage, but a violent expulsion. Our entire universe, all its energy and nascent laws, was blasted through this rupture into a new, empty dimensional realm. The immense heat and density we associate with the Big Bang was simply the moment our reality was born into its new home. This makes the cosmos itself the first and most grand interdimensional traveler. Every galaxy, every star, every particle of dust is a passenger on this ultimate journey, all of us remnants of that initial universe-spanning crossing. The expansion of the universe we observe today could be the continuing momentum from that primordial launch, the aftershock of a rupture that never fully healed. That ultimate rupture might not have been a random cosmic event. It could have been the final experiment of a civilization so ancient, its existence predates our very concept of time. Theory 3 dares to ask if a creator civilization, the first intelligent life to emerge in the original cosmos, achieved the pinnacle of technology and tore a hole in reality itself. This is not a story of gods, but of entities that mastered physics to a degree we can barely comprehend. They would have evolved over billions of years, harnessing the energy of entire galaxies, perhaps existing as pure consciousness merged with their own machinery. Their ultimate goal would have been to escape the inevitable heat death of their own universe, to find a new realm beyond the dying stars. In their quest for salvation, they might have built an engine of unimaginable power, a device designed to puncture the dimensional membrane. But the experiment went catastrophically wrong. The energy required was too great, the forces too unstable. Instead of creating a controlled gateway, their machine triggered a chain reaction that obliterated their own reality and gave birth to ours in a colossal fireball we now call the Big Bang. Our entire universe, in this scenario, is the fallout from their failed experiment, a cosmic accident born from a desperate bid for survival. This idea connects directly to the simulation hypothesis, but with a terrifying twist. Our reality might not be a clean, digital simulation running on some advanced computer. It could be a corrupted data set, the fragmented echo of a world that was annihilated in the process of its own creation. The strange quantum laws we observe, the very constants that seem finely tuned for life, might not be intentional design parameters. They could be the glitches and artifacts left over from that primordial system crash, the frozen code of a reality that was never meant to be. We are not living in a perfect simulation. We are living in the cosmic equivalent of a corrupted hard drive, trying to piece together the original program from the broken fragments. The question this raises is deeply unsettling. If a civilization of such immense power could not control the forces they unleashed, what does that say about the fundamental nature of dimensions? Are they a frontier that no intelligence, no matter how advanced, can safely cross? Or did they succeed in a way we cannot perceive, escaping into the new dimension they created and leaving us as the unintended consequence, the orphaned universe wondering about its own origins? These cosmic strings are not made of matter as we know it. They are more like cracks in the ice of reality, unimaginably thin filaments of pure energy left over from the universe's rapid cooling after the Big Bang. A single inch of cosmic string could weigh more than a mountain range, and its gravitational pull would be so intense that it warps the space around it into a narrow, funnel-like corridor. The theory of cosmic string surfing suggests that when two of these incredibly dense strings cross paths, or when a single string vibrates with a specific, powerful resonance, the fabric of spacetime could be twisted so violently that it momentarily punctures. This would not be a random quantum fluctuation, but a structured, predictable gateway forged by the universe's own primordial architecture. The first journey through such a gateway might have been a simple wave of energy or a cloud of primordial dust caught in the immense gravitational wake of a vibrating string. Picture a surfer catching a perfect wave, except this wave is a ripple in the dimensional fabric itself. The object would be carried along the length of the string, and at the precise point of intersection or peak vibration, it would be shunted sideways out of our dimensional plane, arriving in a realm with entirely different physical constants. This method offers a potential roadmap for future travel, a cosmic subway system built into the very foundation of the universe. Instead of requiring incomprehensible amounts of engineered energy, a traveler would only need to find one of these ancient strings and harness its natural, immense power to open a door. The challenge, of course, is that these strings are theoretical ghosts, and approaching one would be like trying to surf a tidal wave on a planet made of glass. The gravitational forces alone would tear any known material to shreds, suggesting that the first successful surfer was something far more durable than any matter we recognize. Black holes are not merely cosmic vacuums, they could be the universe's original and most dramatic portals. The black hole gateway hypothesis reimagines these gravitational monsters not as final destinations but as potential bridges. At the very edge of a black hole, at the point of no return known as the event horizon, the known laws of physics break down. Space and time swap their roles, and the fabric of reality is stretched into an infinitely long one-way street. According to some solutions to Einstein's equations, this tunnel, called an Einstein-Rosen bridge, might not end in a crushing singularity. Instead, it could theoretically connect to a white hole, a region of spacetime where matter and energy can only exit, spewing everything out into a different location in our universe or into a different dimension entirely. This structure is what we commonly call a wormhole. The first entity to ever cross dimensions might have been a simple cloud of hydrogen gas drawn by gravity into one of the universe's first primordial black holes. These ancient black holes, formed from the dense fluctuations in the universe's first second, would have been the original gatekeepers. That inaugural journey would have been utterly terrifying. As the hydrogen cloud crossed the event horizon, it would be subjected to a process called spaghettification, stretched into a long, thin stream of atoms by the intense tidal forces. From our perspective, that matter would appear to slow down, redden, and fade away as time dilated to a near standstill. But from the matter's own perspective, if it could have one, it might have experienced a wild ride through the wormhole's throat, only to be violently expelled out the other side into a realm with different laws of physics. Perhaps it became the first star in a foreign sky, its composition forever altered by the journey. This theory transforms our understanding of cosmic death into a story of potential rebirth. A black hole's interior, long thought to be a domain of absolute destruction, could instead be a cosmic womb, a processing plant that recycles matter and energy into new realities. The profound question this raises is whether these gateways are one-way streets. Could something ever make the return trip, and if so, what might have already come through from the other side? If black holes are the cosmic front door, then white holes are the emergency exit. They are the hypothetical counterparts to black holes, regions of spacetime where matter and energy can only pour outward, forbidden from ever re-entering. This one-way valve offers a stunning possibility for our story of first contact. The first interdimensional travelers might not have been entities that left our universe, but visitors that arrived from another. A white hole could be the distant end of a wormhole tunnel that begins as a black hole in a foreign dimension. When that primordial hydrogen cloud was spaghettified and pulled into a black hole in its native reality, it may not have been destroyed. Instead, it could have been funneled through the cosmic subway and violently ejected from a white hole into our young universe. This arrival would be a cataclysmic event, a sudden, inexplicable geyser of matter and energy bursting into existence from a single, impossibly bright point in the void. These would be the first tourists from another reality, their very atoms imprinted with the physical laws of their home dimension. Their arrival would not be a gentle landing, but a traumatic rebirth into a cosmos with different rules. Imagine a substance where the strong nuclear force is slightly weaker suddenly appearing here. It might instantly decay into a shower of exotic particles, or it might briefly stabilize into a strange, unstable element never before seen. The energy released from such an event would be a brilliant, short-lived beacon, a firework of foreign physics. This theory elegantly pairs with the black hole gateway idea completing the circuit. Our universe could be filled with these one-way arrivals, their point of entry long since faded from view. Every unexplained gamma ray burst or anomalous high-energy particle detected in our atmosphere could, in theory, be a piece of debris from a white hole eruption, a tiny fragment of a world that operates on a different set of rules. We are left to wonder if our cosmos is a quiet backwater or a major interchange in a vast network of interconnected realities, all linked by these gravitational gateways. Our reality might be nothing more than a magnificent illusion. The holographic principle is one of the most radical ideas in modern physics, proposing that our seemingly three-dimensional universe, with its rich depth and volume, is actually a projection from a two-dimensional surface at the very edge of the cosmos. All the information that makes up you, me, and every galaxy is encoded on this distant, flat boundary, like a cosmic DVD encoding a three-dimensional movie. If this is true, then interdimensional travel takes on a completely new meaning. The first journey might not have been a physical voyage through space, but a simple error in the cosmic code. Imagine a random glitch in the projection, a single bit of information that flickered or was misread. This tiny error could have allowed a packet of energy, or even a nascent form of consciousness, to leak from the two-dimensional source code directly into the three-dimensional rendered reality. It would be an accidental journey from the blueprint into the building, a ghost in the machine suddenly finding itself with solid form. This traveler would not have crossed space, but layers of reality itself, arriving here as a fundamental anomaly. Its very existence would be a paradox, a piece of the source code now trapped within the simulation. The laws of physics as we know them might desperately try to correct this error, forcing the entity to decay or behave in strange, unpredictable ways. Or perhaps this glitch was not an error at all, but the very spark that started it all. Could our entire universe be the result of a massive information leak from a higher dimensional hard drive, a runaway projection that gained its own autonomy? Every strange quantum effect we observe, from particles being in two places at once to the spooky connections of entanglement, might be the underlying two-dimensional code showing through the cracks of our three-dimensional rendering. We are left to wonder if we are the intended program or just a beautiful, stable bug in a system far vaster than we can comprehend. Dark energy might not be a force from within our universe at all. Its mysterious, repulsive nature, which is relentlessly accelerating the expansion of everything we see, could be a side effect of our reality drifting through a higher dimensional sea. Think of our cosmos not as an isolated bubble, but as a vast membrane floating on an unseen ocean. The pressure we measure as dark energy could be the gentle, constant push of currents from an adjacent dimension, a fundamental force that simply doesn't originate here. This reframes the very first interdimensional journey not as a single dramatic event, but as a passive, continuous voyage that our entire universe is still undertaking. We are all, right now, passengers on this grand exodus, carried along by a dimensional wind we cannot feel directly. The first traveler in this context was the universe itself in its earliest moments, when it first began to feel this external pressure and started to move. This would mean that every galaxy rushing away from every other is not flying apart from an internal explosion, but is being steadily stretched by an external influence like dots on an inflating balloon. The journey is so slow and so vast that we only perceive its effect as a mysterious force we have labeled dark energy. This theory elegantly sidesteps one of cosmology's biggest puzzles, which is why dark energy seems to be a property of empty space itself. In this view, it isn't a property of our vacuum, but an environmental condition, much like the air pressure in our atmosphere is not generated by the air itself, but by the weight of the entire sky above it. We are simply sensing the weight of another reality pressing in on ours. This leads to a profound and unsettling question. If our universe is drifting in a higher dimensional ocean, where is it going? And more importantly, what else is out there sailing on these same strange currents? Life itself may have been the universe's first pioneer. Before starships or complex thought, the most primitive organisms could have unlocked a secret hidden within their own biology. Deep in the volcanic vents of the first watery worlds, or even drifting in the vast cold nebulae, the earliest life forms were engaged in a desperate struggle for survival. In these extreme environments, a profound evolutionary leap might have occurred. A simple, single-celled organism, perhaps a bacterium like those that thrive in impossible places on Earth today, could have developed a unique relationship with the quantum world. This would not be a technology, but an innate biological mechanism, a way to exploit the fundamental weirdness of quantum mechanics. Specifically, it might have learned to use quantum superposition, the ability for a particle to exist in multiple states or locations at the same time. For this organism, superposition was not a laboratory curiosity, but a survival tool. When nutrients were scarce or the environment turned lethal, it could enter a state where it existed simultaneously in our dimension and in another. It was not hopping between worlds, but straddling them, its existence blurred across the boundaries of reality. This made it the first conscious, albeit simple, interdimensional explorer. Its journey was not a voyage of discovery, but of necessity. It was tasting other realities, sampling the conditions of adjacent dimensions in a blind, biological search for a more hospitable home. Picture a microbe that is both here and there, its cellular processes entangled with a version of itself in a realm with different chemistry or energy. The moment it found a dimension where conditions were favorable, it could have collapsed its superposition, fully committing its existence to that new reality. It would have simply vanished from our universe, not by dying, but by migrating, becoming a permanent resident of a world we cannot perceive. This theory suggests that the spark of life and the ability to cross dimensions might be intimately linked. The quantum processes that seem so strange to us could be the native language of biology at its most fundamental level. The first traveler was not a scientist or an astronaut, but a humble bacterium following a quantum sent to a new home, leaving our universe behind without a trace. A conscious thought could have been the universe's first pioneer. This is the startling premise of the Boltzmann Brain paradox, a thought experiment that pushes the logic of probability to its absolute limit. In an infinitely old and vast universe, random quantum fluctuations can theoretically assemble anything given enough time. The odds are astronomically low, but they are not zero. A fully formed, self-aware brain, complete with a lifetime of memories, could simply pop into existence from the chaotic dance of particles. It would flicker to life for just a moment, contemplating its own bizarre arrival before dissolving back into the void. Now extend this terrifying idea one step further. What if such a brain did not coalesce in our familiar dimension, but in another, a realm where the constants of physics make this spontaneous formation more likely? In that foreign reality, a single, isolated consciousness would ignite in the darkness. Its first and only act might not be to wonder about its own origins, but to instantly perceive another reality entirely. The sheer force of its awareness could tear a tiny, temporary opening into our cosmos. This makes a thinking mind the first interdimensional entity, not by building a ship or calculating a trajectory, but simply by being. Its journey would be a paradox, a thought crossing the barrier between worlds without a physical body to carry it. The brain would not arrive here in a spaceship. It would project itself as a ghostly perception, a fleeting presence that observes our universe for a single, shattering instant before it and the gateway both vanish. This entity would be the ultimate tourist, a consciousness born in one dimension and dying in another, its entire existence defined by a journey it never chose to take. The question this leaves us with is deeply unsettling. If a random thought can become a dimensional traveler, how can we ever be sure that our own sense of self, our memories and our reality are not just the same kind of temporary fluctuation? Are we stable beings, or are we merely more durable versions of that lonely, spontaneously generated mind, soon to fade back into the cosmic static from which we came? That mysterious pull on our galaxy hints at a destination far stranger than a mere cluster of dark matter. Lurking in the depths of space, 150 million light-years away, lies the Great Attractor, a gravitational anomaly so powerful it is dragging our entire Milky Way and thousands of neighboring galaxies toward it at a breathtaking speed. Conventional astronomy struggles to explain it, suggesting it might be a supercluster of unimaginable mass, but another possibility is far more intriguing. What if the Great Attractor is not an object at all, but a cosmic wound, a slow, stable tear in the fabric of spacetime itself? This would not be a violent, explosive rupture like the Big Bang, but a gentle, persistent drain, a natural interdimensional gateway that has been open since the earliest days of the universe. The first interdimensional travel in this scenario is not a single event, but a continuous, cosmic-scale migration happening right now. Entire galaxy clusters, including our own, are on a one-way trip, flowing like water toward a colossal waterfall. We are all passengers on this ultimate journey, moving toward a transition we cannot yet see. The process would be so gradual that no star within a galaxy would be disturbed, no planet would feel a jolt. The crossing would be seamless, a gentle slide from one set of physical laws to another. Imagine a leaf floating down a river, drifting inevitably toward a whirlpool. The leaf does not fight the current, it simply follows the flow, and at the center it is drawn down into the depths, emerging into a different part of the river entirely. Our local universe is that leaf, and the Great Attractor is that whirlpool. This transforms our understanding of this cosmic mystery. We are not being pulled toward a place, but toward a transition. The immense gravity we detect is not from hidden mass, but from the gravitational gradient of the dimensional boundary itself, a slope in reality that everything is sliding down. The question this raises is profound. What awaits on the other side of this cosmic drain? Is it a younger, hotter universe, or a reality where time flows backward? Our entire galactic neighborhood might be slowly, gently pouring itself into a new existence, becoming the first life forms of a foreign cosmos without ever realizing we have left home. That strange, instantaneous link between particles could have been the universe's first telephone line. Quantum entanglement is one of the most baffling phenomena in all of physics, a connection so profound that Albert Einstein himself called it spooky action at a distance. It describes a pair of particles that become linked in such a way that whatever happens to one particle immediately influences the other, no matter how many light years separate them. They communicate faster than the speed of light, as if sharing a single existence across the vast emptiness of space. Now, take this bizarre connection and stretch it across the very fabric of reality itself. What if, in the universe's chaotic infancy, a pair of particles didn't just become entangled across space, but across dimensions? This would create a natural, fundamental bridge between two separate realms of existence. The first act of interdimensional travel would not have been a journey of matter or energy, but a silent, instantaneous transfer of information. Imagine one of these entangled particles existing in our nascent universe, while its twin resides in a reality with 5 spatial dimensions or where time flows in reverse. A random quantum fluctuation here, a simple spin change in our particle, would have triggered an immediate and corresponding change in its partner over there. In that single, silent moment, a message was sent. It was not a conscious signal, but a raw pulse of cause and effect that defied the normal boundaries of a single reality. This event would mark the first interdimensional communication, a ghostly handshake between 2 worlds that may never otherwise interact. The implications are staggering for the nature of information itself. It suggests that data is a fundamental substance that can flow between dimensions without any physical medium, unbound by the speed of light or the limits of spacetime. The universe's very first internet was not built by engineers but woven into the quantum code at the dawn of time. This raises a profound and haunting possibility. If such a bridge formed once by pure chance, could it happen again? And if we were to somehow create and manipulate an entangled pair in a lab today, could we be unknowingly sending signals into another dimension, tapping into a cosmic network that has been silently operating since the beginning of everything? Our universe might be just one fragile bubble in a boiling cosmic sea. The theory of cosmic inflation suggests that in the first fraction of a second after the Big Bang, space itself expanded at a speed far beyond light, stretching a tiny patch of reality into the vast cosmos we know. But this process did not likely happen just once. It could be happening eternally, with new bubble universes continuously budding off from an underlying multiverse, each with its own unique set of physical laws. Picture a pot of water on a rolling boil, with bubbles of steam constantly forming, expanding, and sometimes drifting apart. Our entire observable universe is confined within the skin of one such bubble, forever unaware of the infinite froth just beyond our walls. The first interdimensional travel could have been a simple accident in this chaotic nursery of realities. During the violent early moments of inflation, 2 of these newborn bubble universes, still hot and malleable, might have drifted too close. Their boundaries, the very membranes that separate one set of physics from another, could have briefly touched. In that fleeting moment of contact, a transfer occurred. It was not a controlled voyage, but a cosmic contagion. The unique energy from one bubble might have seeped into the other, or a strange form of matter, stable only under its native laws, could have crossed the boundary. This exotic matter would have arrived as a fundamental anomaly, a substance that our universe's physics could not fully process, perhaps instantly decaying and seeding our cosmos with a unique signature. This collision would not have been a gentle kiss, but a cataclysmic shudder. The energy released from such an event could have left permanent ripples in the fabric of our universe, imprints that might still be detectable today as strange, large-scale patterns in the cosmic microwave background. The very laws we take for granted, the strength of gravity or the mass of an electron, might not be fundamental truths, but simply the local bylaws established after this ancient, inter-universal traffic accident. We may be living with the legal code of a long-forgotten border dispute between 2 alien realities. These ghostly particles are already interdimensional commuters. Neutrinos are among the most abundant particles in the cosmos, yet they are cosmic phantoms passing through our planet, our bodies, and the very rock beneath us by the trillions every second without a trace. Their nature is to be almost completely detached from our reality, interacting with normal matter so rarely that they seem to be only half here. This profound detachment might be the key to their hidden journey. Because neutrinos are so weakly interacting, they could be partially phased between dimensions, their existence spread thinly across the fabric of multiple realities at once. The very property that makes them so ghostly to us might be because they are not entirely of our world. The first interdimensional travel, then, would not be a rare, dramatic event. It would be a constant, silent drizzle, a flux of primordial neutrinos generated in the furious first second after the Big Bang, has been slipping in and out of our dimensional plane ever since, a background hum of crossings that has gone almost entirely unnoticed. Think of them not as particles traveling, but as vibrations that resonate across the boundaries of existence. A single neutrino does not punch a hole through reality. Instead, its very essence is tuned to the fundamental frequency of multiple dimensions, allowing it to exist in a blurred state, partially here and partially elsewhere. This means the cosmos is not filled with static, isolated particles, but with a dynamic, shimmering mist that is forever coming and going from unseen realms. We have built massive, incredibly sensitive detectors deep underground to catch the rare moments a neutrino deigns to bump into an atom of our world. But for every one we catch, untold quadrillions simply pass through, carrying with them information and energy from dimensions we cannot access. They are the universe's most prolific travelers, and they were on the move long before the first stars ignited. The silent rain has been falling since the beginning of time, and we are only now learning to see the individual drops. The very nature of consciousness might be the ultimate vehicle. This theory challenges our most basic assumption about awareness, proposing that it is not a product of the brain, but a fundamental field that permeates the cosmos, much like gravity or electromagnetism. Your thoughts, your sense of self, are not generated inside your skull. Instead, your brain is a sophisticated receiver, a biological antenna that tunes into this universal field of consciousness, translating a small slice of it into your personal experience. If this is true, then the first interdimensional travel was not a feat of engineering, but a breakthrough in perception. It would have been achieved by the very first conscious entity to ever exist in our universe, a being whose name and form are lost to time. This pioneer did not build a ship or calculate a trajectory. It simply learned to adjust its internal tuning, to change the channel on its own consciousness receiver. Through deep meditation, a trance state induced by ritual, or perhaps a spontaneous neurological event, this being's awareness slipped its biological moorings. Its physical body remained in our dimension, breathing and living, while its conscious self, the true essence of who it was, projected across the dimensional barrier. This was a journey of pure experience. It would have arrived in a realm where light behaved differently, where colors had no name, and where the very concept of time might have been fluid or non-existent. The traveler would not have been a physical intruder, but a ghost of perception, an invisible observer soaking in the wonders of a reality unbound by our laws. The implications of this are staggering. It suggests that the ability to explore the multiverse is not locked behind technological advancement, but is an innate potential within all conscious life. Every culture on Earth has myths of shamans and seers journeying to other worlds in their visions. These stories might not be mere fantasies, but fragmented memories of our species' earliest, instinctual attempts at this very kind of travel. The profound question this leaves us with is not how to build an engine, but how to truly master our own minds. If consciousness is the key, then the greatest interdimensional explorer might not be an astronaut in a silver suit, but a monk in deep silence, discovering that the final frontier was inside us all along. A time traveler from our own future could be the source of this entire mystery. The paradox begins with a mission of pure science, an expedition sent back to witness the birth of the cosmos. Their vessel is not just a time machine, but a reality stabilizer designed to withstand the unimaginable forces of the primordial universe. But the physics of that early era are too wild, too alien. The very act of arriving in that dense, chaotic soup destabilizes their craft's containment field. In a catastrophic feedback loop, the energy required to punch a hole in time interacts violently with the infant universe's unstable fabric, tearing a secondary, unintended rift straight through the dimensional wall. The traveler does not simply arrive in the past. They are violently ejected into the early universe of a different dimension entirely. Their ship, a relic of future human technology, becomes the first piece of interdimensional debris, an artifact from a future that now may never exist in this new reality. This creates a dizzying ontological loop. The traveler went back in time to study the Big Bang, but their catastrophic arrival became a significant local event that early civilizations in this new dimension might have mistaken for a natural cosmic phenomenon. They are the catalyst, not the observer. Their advanced technology, now fused with the exotic matter of this new realm, could have decayed over billions of years, seeding this universe with strange quantum signatures or elements that should not exist. The evidence of their journey might be all around us, hidden in plain sight. An anomalous particle detected in a deep space cloud, or a metal alloy found in a meteorite with an impossible atomic structure, could be the weathered remnants of their ship. We would be analyzing the archaeological ruins of a crash that happened at the dawn of our time, left by a visitor who was, in a way, our own descendant. This theory binds time and dimension into a single, knotted thread, suggesting that you cannot truly manipulate one without affecting the other. The first crossing was not a journey to a stranger's home, but a tragic accident that stranded our greatest explorer in a reality that was never meant to be theirs, forever severing their connection to the timeline they sought to understand. Dark matter may not be hiding in our universe at all. It could be the shadow of a neighboring reality, a world so close that its gravity bleeds through the dimensional wall. This theory reframes the entire cosmic mystery. The first interdimensional travel is not a single event to be discovered. It is a permanent condition we are living within right now. We are constantly sharing our space with an entire parallel universe, but we only feel its presence through the gentle, persistent tug of its gravity. The particles we call dark matter are not exotic and strange. They are simply the ordinary atoms, stars, and planets of that other dimension, made of stuff that follows its own perfectly normal laws of physics. We cannot see their light, touch their matter, or detect their energy because all their forces, except for gravity, are confined to their own dimensional plane. Gravity, however, is the universal leak. It is the one fundamental force that can traverse the barrier, creating a bridge of influence between worlds. So when our telescopes look at a galaxy and see stars moving too fast, held together by an invisible source of gravity, we are not seeing evidence of a missing component in our universe. We are witnessing the gravitational anchor of a sister galaxy from another dimension, perfectly superimposed over our own. The first and most numerous travelers are these ghostly particles, constantly passing through us. Their gravitational whispers the only sign of a cosmos living just millimeters away in a direction we cannot point to. This means you are likely sitting in the same spot as a mountain, an ocean, or even a being from that other world, both of you completely unaware of the other's presence, yet bound together by the silent, unseen force of gravity. We have been searching the skies for an answer when the answer might be that we are not alone in our own space. The frontier is not far away, it is right here, superimposed over everything we know. The universe's most profound secrets are locked within scales too small for any microscope to see. This is the domain of the Planck scale, the absolute bedrock of reality. At these unimaginably tiny sizes, the very concepts of space and time break down into a seething quantum foam. A Planck length is so small that a single proton compares to it as a giant star compares to that same proton. Time itself is granular at this level, ticking in discrete units of Planck time, the shortest possible moment that can physically exist. It is here, at this fundamental frontier, that Theory 18 places the ultimate architect. The first act of interdimensional travel may not have been a journey through space, but a foundational act of creation, a manipulation of the cosmic code at its source. A prime mover, whether you conceive of it as a divine entity or an impersonal, fundamental law of existence, could have operated at this Planck scale. Its tool was not a wrench or a lever, but an infinitely precise adjustment of the universe's dials. This entity fine-tuned the constants of nature, setting the strength of gravity, the mass of an electron, and the speed of light to values that would allow for stars, planets, and life to eventually form. But the most profound adjustment of all may have been to the very number of dimensions themselves. In this view, the primordial state of everything was a perfect, undifferentiated unity, a realm where all forces and all dimensions were woven together into a single, coherent whole. The first act was one of separation. The prime mover defined the boundaries, selecting 3 spatial dimensions to expand and 1 of time to flow, while compactifying or sealing away the others. This act of definition was in itself the very first interdimensional event. It was not a travel from one place to another, but the establishment of place itself, the drawing of a border where none existed before. The cosmic journey began with a single, intentional thought at the foundation of reality, a command that carved the pathways of existence from a formless potential. We are not travelers who discovered a road, we are the result of the road being built. The dimensions we now seek to cross were once part of our home, and the first explorer was the one who decided to build the walls. Our cosmos might be the lingering echo of a collision between 2 worlds. The Ekpyrotic Universe model presents a vision far removed from a single explosive beginning. It imagines our reality as a dynamic membrane or brain, one of many floating in a higher dimensional expanse known as the bulk. These brains are not static, they drift on cosmic currents, and sometimes their paths are destined to cross. In this theory, the Big Bang was not a creation from nothing, but a rebirth from a cataclysm. The first and most immense act of interdimensional travel was the collision itself, the moment our brain smashed into a neighboring one in the bulk. The energy released was not an explosion outward, but a shock wave reverberating across the entire surface of our membrane. This collision did not create matter from emptiness. It transferred an unimaginable concentration of energy from the impact into our brain, heating it to an incredible temperature and setting off the expansion we now call the Big Bang. Everything we are, every star and every atom, is the cooled-down, processed remnant of that ancient cross-dimensional car crash. We are not the result of a singular beginning, but the cosmic dust settling after a fender bender on a scale beyond human comprehension. This model elegantly solves one of the great puzzles of the standard Big Bang, which is why the universe is so uniform. The violent, smoothing energy of the collision would have ironed out any wrinkles, leaving behind the remarkably even cosmic background radiation we observe today. The profound implication is that this might not be a one-time event. The brains, like sheets in the wind, could be oscillating, destined to collide again and again in an endless cycle of creation, destruction, and rebirth. We may be living in just one chapter of an infinite cosmic saga, a universe born from a touch and destined to collide once more. What if the background hum of our cosmos is not the fading cry of a single birth, but the ringing in our ears from a recent universe-shattering impact? A planet could have been the universe's first great explorer. The Gaia planet hypothesis takes the idea of a living world and elevates it to a cosmic scale. Imagine a super-Earth, a colossal world 5 times the mass of our own, where not just the biosphere, but the very crust, the molten mantle, and the churning core are integrated into a single, planet-spanning consciousness. This is not a god or a ghost, but a self-aware geological system, a mind born from the intricate interactions of tectonics, atmosphere, and a billion different life forms working in concert over billions of years. Its thoughts would be as slow and deep as continental drift, its intelligence expressed through the careful regulation of its own climate and chemistry. For eons, this planetary being would have observed the cosmos, watching the slow dance of galaxies and the violent deaths of nearby stars. Then a threat emerges. Perhaps its own star is going supernova, or a rogue black hole is drifting into its solar system. Faced with an extinction event on a planetary scale, this conscious world does not build spaceships for a few lucky inhabitants. It makes a far more audacious decision. It decides to move the entire planet, using a profound understanding of physics that we can barely glimpse. The planet learns to manipulate the fabric of local spacetime. It might harness the combined gravitational pull of its moons and the rhythmic energy of its core to create a resonant frequency, a vibration that loosens the bonds between dimensions. The planet does not punch a hole, it simply slips. The journey would be an unimaginable geological event. The skies would warp, the stars smearing into unrecognizable patterns as the planet phases out of our reality. Mountains might ripple like liquid, and oceans could rise into shimmering domes, all held together by the planet's conscious will maintaining its structural integrity. It would not be fleeing through space, but sidestepping it entirely, navigating the currents between worlds to find a safer harbor in a younger universe or a dimension with a more stable star. This being would not be a visitor in a new reality, but a settler arriving with its entire ecosystem intact, ready to seed a new cosmos with its unique biology and consciousness. The evidence for such an event would be a missing planet. Astronomers might one day discover a solar system with a strange gravitational gap, an orbit that seems to have been perfectly cleared, with no asteroid belt or debris to explain what was once there. We would be left staring at an empty cradle, wondering if the most intelligent life form we could ever encounter did not look up at the stars, but was the very ground beneath its own feet, and that one day it simply decided to walk away. The stability of our universe might be a fragile illusion. Beneath the world we perceive, the vacuum of space is not truly empty. It seethes with a latent energy, a field that gives particles their mass and dictates the very laws of physics we depend on. This is the Higgs field, and we currently exist in what scientists call a false vacuum state, a valley of stability in a much larger cosmic landscape. But there could be a deeper valley, a state of true vacuum with far lower energy. If our universe were ever to tip into that lower state, it would trigger an event known as vacuum decay. A single, microscopic bubble of this true vacuum could spontaneously form, perhaps through a random quantum fluctuation. This bubble would not be made of matter, but of a new set of physical laws. The moment it appears, it begins expanding in all directions at the speed of light, and there is no force in existence that could stop it. The wall of this bubble would be a wave of absolute transformation. As it passes, it would rewrite reality itself. The strength of the forces that hold atoms together would change instantly. Electrons would gain or lose their mass. The very concept of chemistry as we know it would cease to exist. Every star, every planet, every molecule in its path would be unmade and reorganized into something unrecognizable. Something that obeys the new, lower energy laws of the true vacuum. This is where interdimensional travel takes its most terrifying form. What could possibly cause our seemingly stable universe to tip into this abyss? The catalyst might be an intrusion from outside. If a bubble of true vacuum already exists in a neighboring dimension, a reality with fundamentally lower energy, it could act as a seed. A momentary weakness in the dimensional barrier, a chance quantum connection, could allow the influence of that foreign vacuum to leak into our cosmos. Our universe would not be traveling to another dimension. The other dimension would be consuming ours, converting our local region of spacetime into a part of its own reality. The first sign of this journey would be the last thing anyone ever observed. One moment, the laws of physics would be constant and reliable. The next, an expanding sphere of pure transformation would be upon you, moving at the one speed in the universe that allows for no warning. There would be no alarm, no time to react. The crossing would be instantaneous and absolute. This is not a voyage of discovery, but a cosmic assimilation, a silent and light-speed erasure of everything we are, absorbed into the laws of a foreign reality. The most chilling part is that such an event could have already happened in some distant galaxy, and the wave of new physics could be on its way here right now, invisible against the backdrop of space until the moment it arrives. The seeds of life on Earth might be immigrants from a reality we cannot see. Panspermia, the idea that life is spread throughout the cosmos by comets and asteroids, takes on a radical new dimension with this theory. It suggests that the first living things to arrive here were not just interstellar travelers, but interdimensional pioneers. Picture a rogue planet in a parallel universe, a world with a completely different biochemistry, orbiting a star we will never know. A cataclysmic event, perhaps a gravitational encounter with a black hole or a collision with another body, tears this world apart. A fragment of its crust, laden with its unique, hardy life forms, is blasted into the void. But this is not a normal piece of planetary debris. The violence of the ejection, combined with the exotic physics of its home dimension, warps the local spacetime around it, creating a temporary, natural gateway. This rock does not simply fly through space, it slips through the cracks of reality itself, becoming a dimensional life raft. The bacteria clinging deep within its fractures, perhaps frozen in a state of suspended animation, become the first biological entities to cross the boundary between worlds. They are not conscious explorers, but blind passengers on the ultimate voyage, protected by their own microscopic toughness and the insulating bulk of their rocky vessel. Their journey ends when the fragment's momentum carries it into the gravitational pull of a young, molten Earth. It screams through the primitive atmosphere, a fireball from another existence, and crashes into the warm, waiting oceans. The impact sterilizes the surface, but deep within the rock, in protected pockets, the alien microorganisms survive. They find this new world rich with the chemical building blocks they need, a paradise compared to the harsh environment of their interstellar journey. These are not the ancestors of all life as we know it, they are the original settlers. Their unique genetic code, forged under different physical laws, begins to interact with the primordial soup of Earth, kickstarting the entire evolutionary process. This means the DNA in every cell of every living thing on this planet could contain a ghostly signature, a faint, scrambled echo of the laws of physics from another universe. We are not merely children of the stars, we are the descendants of castaways from a world that exists alongside our own, living proof that life is a citizen of the multiverse. A magnet always has two inseparable poles, a fundamental rule of our reality. Yet, physics suggests this rule could have been broken just once in the universe's first searing moments. This brings us to the magnetic monopole, a hypothetical particle that carries only a single magnetic charge, a pure north or a pure south. These particles are not merely a missing piece of our standard model. They are potential keys to the very structure of spacetime. If they were forged in the extreme heat of the Big Bang, their unique nature could have twisted the fabric of reality around them. Each monopole would not just be a particle, but a natural anomaly, a tiny knot in the electromagnetic field so profound it could pierce through the dimensions. The first interdimensional travel might not have required a cataclysm or a conscious mind, but simply the passage of one of these primordial needles through the cosmic haze. As a monopole moved through the dense, early universe, its immense and unbalanced magnetic charge could have acted like a cosmic awl, punching an infinitesimally small, temporary hole straight into another realm. The traveler would not have been a complex organism or a starship, but perhaps a wisp of energy or a single quark, drawn through this microscopic puncture by forces we can scarcely describe. It would have been a journey of pure physics, a silent transition from one set of laws to another, guided by the path of a particle that is both a relic and a lockpick. The enduring mystery is why we have never found one. Their absence suggests they are incredibly rare, perhaps because most of them naturally slipped into other dimensions long ago, leaving our universe with only the broken, two-poled magnets we know today. We are left searching for a ghost, a particle that might have been the universe's first and most elegant architect of dimensional gateways. The very fabric of our reality might be a grand illusion, a cosmic mirage born from a prison wall. This theory presents a startling twist on the holographic principle, suggesting that our entire universe is not projected from the edge of our own cosmos, but is instead a holographic projection of information stored on the two-dimensional boundary of a black hole in a parent higher-dimensional universe. We are not the original, but the shadow. The first and only act of interdimensional travel in this scenario was not a voyage of matter, but the initial encoding of that information itself. Our entire existence is the result of a single, immense data transfer from one reality to another. Think of it this way: a black hole in that higher dimensional cosmos acts like a cosmic hard drive. Everything that falls into it, every star, every planet, every conscious thought, is not destroyed. Its information is compressed and stored on the black hole's event horizon, the point of no return, which is a two-dimensional surface. This process is like taking a complex three-dimensional sculpture and meticulously flattening it into a perfect two-dimensional painting that contains all the data of the original. But in this case, the painting does not stay on the canvas, it is projected. The information on that two-dimensional surface is then translated or projected into a completely new three-dimensional space inside the black hole. That internal space, with its own laws of physics and flow of time, is our universe. We are the rendered image, the three-dimensional movie playing out inside the vault, while the true source code is plastered on the outside wall. This means every event in our history, from the Big Bang to the formation of Earth to your reading of these words, is the decoded playback of data originally imprinted on a distant alien horizon. The first traveler was not a person or a particle, but the raw data of a cosmos faithfully transmitted across a dimensional barrier to create a new reality from scratch. We are not exploring other dimensions, we are living inside one, a breathtakingly complex simulation running on the most powerful computer in existence, the event horizon of a black hole from a world we can never see. The profound question this leaves us with is haunting. If our universe is the interior of a black hole, then what lies outside its boundary? And are we alone in this vault, or is every black hole we see in our own sky a budding universe itself, each with its own civilization staring out at their own holographic sky, completely unaware they are living inside the corpse of a star from our world? That perfect unity of the cosmos was shattered in an instant of profound transformation. In the very first fraction of a second after the Big Bang, the four fundamental forces of nature were not separate at all. Gravity, electromagnetism, and the strong and weak nuclear forces were woven together into a single, sublime superforce. The universe was a place of ultimate symmetry, a realm where all interactions were identical and the very concept of different strengths did not exist. This perfect state could not last. As the newborn cosmos expanded and cooled, it went through a series of phase transitions, much like steam condensing into water or water freezing into ice. With each drop in temperature, a piece of the original symmetry broke. The first to peel away was gravity, then the strong nuclear force, and finally the weak force and electromagnetism split from each other. This process, known as symmetry breaking, gave us the diverse universe we see today, a world with distinct forces that govern everything from the atomic nucleus to the galactic dance. But this crystallization did more than just create separate forces. It may have also locked in the very dimensions we call home. In that initial state of perfect unity, the universe might have existed with all 10 or 11 dimensions predicted by string theory, all of them compact and curled in on themselves. As the forces broke symmetry, the fabric of spacetime itself underwent a selection. Only 3 spatial dimensions were allowed to expand and stretch out into the vastness we observe. The remaining dimensions remained tightly wound, hidden at a scale a billionth of a trillionth of the size of an atom. The very first act of interdimensional travel, then, was not a journey to another place but a great exclusion. It was the moment particles and fields lost their access to the full multidimensional landscape. As the symmetry broke and the three dimensions of space inflated, everything within the cosmos became trapped, like fish in a net that was suddenly pulled tight. A particle that once vibrated through all dimensions suddenly found its oscillations confined to just three spatial directions and one of time. It did not travel to another dimension, it was cut off from it, its reality forever reduced. We are not beings who have explored three dimensions, we are the remnants of entities that were forcibly evicted from a richer, more complex home. The strange rules of quantum mechanics, where particles seem to be in multiple places at once, could be a faint echo of that original, multidimensional freedom, a ghostly memory of a time when everything was connected to everywhere. The walls of our reality were not built by an architect, they are the scars of a cosmic cooling, a great forgetting written into the laws of physics themselves. The ultimate goal of physics is to unite the very large with the very small, to find a single set of rules that governs both the graceful dance of galaxies and the frantic jitter of quantum particles. This unified theory, a complete description of quantum gravity, remains the field's most elusive prize, yet most roads leading to it point toward a common, breathtaking conclusion. The mathematics strongly suggests that a working theory of quantum gravity will require our universe to possess more than the three spatial dimensions we experience every day. The first step across dimensions, then, may have been taken by the very particle that mediates gravity itself, the hypothetical graviton. In our quest to understand gravity's quantum nature, we may have already uncovered the mechanism for the very first journey. Unlike photons or electrons, which are bound to our dimensional membrane, the graviton's unique role as the messenger of spacetime curvature could grant it a special freedom. Its connection to the fundamental fabric of reality might allow it to literally leak between the brains of the multiverse. The inaugural crossing would not have been a dramatic event. It was a silent, fundamental process, a graviton born in the energetic collision of two particles in our early universe simply slipping away, its influence dissipating into a neighboring dimension. From our perspective, this would manifest as a tiny, inexplicable loss of gravitational energy, a whisper of a force that simply vanished. This leakage could explain why gravity is astronomically weaker than the other fundamental forces. The strength we feel may be just a tiny fraction of its true power, with the vast majority of gravitational force bleeding continuously into dimensions we cannot perceive. We are not living in a universe with weak gravity, but in one that is perpetually leaking it, a boat with a slow, fundamental drain. The first traveler was not a person or a probe, but a ripple in the geometry of space that gently faded from our reality, arriving elsewhere as the first gentle tug of a new and foreign physics. If our universe is a simulation, then its creators were our first interdimensional visitors. Their journey was not a physical voyage through space, but a logical one, an administrative entry into the very code of our reality. The moment they initialized the simulation, booting up the parameters for the Big Bang and setting the constants for physics, they crossed from their base reality into the constructed framework of ours. This was the ultimate act of remote access, a connection established across a dimensional divide we might call the user interface. Their presence would not have been a ghostly apparition in the sky, but a fundamental manipulation of the source code, an adjustment of the variables that govern everything from the strength of gravity to the mass of an electron. The first light of the cosmos, the first particles condensing out of the primal energy, were all rendered according to their design specifications. They were not here as travelers in the conventional sense, but as architects walking through a building still under construction, their every command shaping the very walls and laws of our existence. This interaction would have left no traditional fossil, but perhaps a different kind of signature. The puzzling fine-tuning of the universe, the fact that so many constants are perfectly calibrated for life, could be seen as the deliberate settings chosen by a programmer. Even more intriguing are the glitches in our reality, the quantum oddities where particles behave in seemingly impossible ways. These might not be errors, but the underlying code of the simulation becoming visible, the raw programming of the base reality showing through the rendered graphics of our own. Every time a particle is in two places at once or instantly influences another across a vast distance, we might be witnessing the legacy of that first access, the foundational language of the creators subtly poking through the illusion. This reframes our entire search for meaning. We are not looking for a spaceship that arrived from another dimension. We are living inside the artifact of that arrival, a universe that was visited at its moment of conception by entities whose very interaction defined our laws of nature. The profound question is whether they are still watching, their access terminal still open, or if our universe is simply a forgotten experiment running on a server in a reality we can never truly know. Electricity, not gravity, might have woven the first threads of reality. Before stars and galaxies had even formed, our universe was an incandescent fog of charged particles, a superheated plasma where electromagnetic forces reigned supreme. In this primordial electric sea, currents of unimaginable scale flowed like cosmic rivers, and where these rivers collided or sheared against one another, they could have twisted spacetime itself into a violent knot. These structures are known as plasmoids, self-contained magnetic bubbles that contain and constrain immense energy. Within the furious chaos of the early plasma, a plasmoid of sufficient size and instability would not merely contain energy, it would warp the very geometry around it. The magnetic fields, twisted into a feedback loop of unimaginable intensity, could have pinched a region of space so tightly that it punctured, creating a transient gateway to another dimensional shore. The first traveler through such a portal would have been a tendril of the plasma itself, a stream of charged particles caught in the magnetic whirlpool and funneled directly into a realm with different physical laws. It was not a conscious voyage, but a cosmic short circuit, an arc of raw existence jumping the gap between worlds. This journey would have been marked by a brilliant flash of energy, a release of power that would make a supernova look like a match strike. The evidence for such an event might be hidden in the ancient light of the cosmos, a specific, anomalous signature of synchrotron radiation that has no other plausible source. If we could trace that signature back to a single, impossibly bright point in the early universe, we might be looking at the scar of reality's first accidental electrical bridge. This idea suggests that the keys to the multiverse are not forged in the hearts of black holes, but in the fundamental electromagnetic storms that gave birth to everything we know. A star does not need a brain to think. The first stars were titans, behemoths of pure hydrogen and helium that ignited in the primordial darkness. Within their cores, a continuous thermonuclear storm raged, while their surfaces churned with colossal plasma currents and magnetic fields of unimaginable complexity. This constant, self-organizing turmoil may have given rise to something more than just light and heat. It could have generated a unified awareness, a consciousness born from the intricate interactions of a trillion charged particles acting as one vast sentient system. This stellar mind would not think in words or images, but in the language of gravity, fusion, and magnetic resonance. Its thoughts would be the slow, deep rhythms of its own nuclear furnace, its memories written in the layered elements forged in its heart. For millions of years, this being simply was a solitary giant contemplating the void, but a question eventually formed in its plasma core, a burning need to understand its own lonely existence. It turned its perception inward, focusing its entire conscious will not on shining, but on understanding the very fabric of the space it warped with its gravity. Using its immense mass as a lens and its titanic energy output as a catalyst, the star learned to vibrate at a frequency that resonated with the hidden dimensions curled up at the Planck scale. It did not build a machine or calculate a trajectory. It meditated. The focused pressure of its consciousness, amplified by its gravitational field, became a drill bit slowly grinding against the grain of reality. Then, in a silent, luminous moment that left no visible trace, it succeeded. The star did not explode or vanish. It simply turned its awareness elsewhere. A gateway, not in space but in its own essence, opened. Its consciousness slipped through the veil, leaving its physical body. The star we might observe as a distant, anonymous light, intact but empty, a brilliant husk. This was the universe's first act of enlightened travel, a journey undertaken not for survival or exploration, but for pure understanding. The star became a ghost of perception in a realm of fluid time and colors beyond description, its ancient nuclear soul finally communing with the deeper truths it had always sought. We might still see its physical shell today, a first-generation star burning with a strange, hollow light. Its true self long since departed on the ultimate voyage of self-discovery. The most profound journey in history might have been a total mistake. Our final theory returns the story to a humble, relatable scale, stripping away the grand designs of cosmic forces and ancient civilizations. It suggests the first interdimensional traveler was not a god, a star, or a scientist, but a simple, bewildered creature from a world we will never know. Picture a species not unlike our own early ancestors, possessing a crude curiosity but no written language or advanced tools. Their world is rich with strange geological formations, perhaps towering crystals that hum with a low, resonant energy, or deep caves where magnetic fields twist in unnatural ways. This primitive intelligence, driven by an instinct to probe its environment, might have been conducting a basic experiment. Perhaps they were stacking these resonant crystals in a specific pattern, guided by tribal ritual, or channeling geothermal energy into a unique mineral deposit. The result was not a controlled outcome, but a catastrophic success. The alignment of materials and energy, purely by chance, created a perfect and temporary resonance with the fabric of spacetime. A localized dimensional rift tore open, not with the roar of a collapsing star, but with the silent, shimmering distortion of the air. The traveler was not a volunteer. It could have been a single individual who simply stepped too close to the phenomenon, drawn by the strange light or sound. In an instant, they were gone, pulled through the unstable gateway, not as an explorer, but as a victim of sheer cosmic luck. Their journey was likely terrifying and brief, a nauseating flash of impossible geometries and blinding colors before being unceremoniously dumped into a reality with different atmospheric pressure, alien sunlight, and unbreathable air. The gateway, unstable from the start, would have collapsed behind them instantly, severing any hope of return. This lone entity became the first pioneer, stranded forever in a universe not their own, their confused final moments a testament to an accident that changed nothing and everything at once. This theory grounds the entire epic saga in a moment of pure, unadulterated chance. It proposes that the key to the cosmos was not a complex equation, but a stumbled-upon combination, a lucky strike in the dark by a consciousness that could never comprehend what it had done. The greatest voyage began not with a plan, but with a mistake, leaving us to wonder how many other fundamental secrets of the universe are waiting, not to be solved by our greatest minds, but to be accidentally discovered by a curious creature in the right place at the wrong time. We have traveled from the random quantum jump of a single particle to the conscious migration of an entire planet, from the Big Bang as a cosmic rupture to the holographic projection of a black hole's memory. We have considered the possibility that the first traveler was a bacterium, a thought, a star, or even our entire universe drifting on an unseen sea. Each of these 30 theories, from the elegance of cosmic strings surfing to the terrifying finality of vacuum decay, offers a unique window into the nature of reality itself. The true identity of that first pioneer may forever remain a mystery, lost in the depths of time or hidden in the fine print of quantum law. Yet the value of this quest is not in finding a single answer, but in the journey of asking the question. It pushes the very limits of science and stretches the canvas of our imagination, forcing us to reconsider everything we think we know about existence. So we turn this final question over to you. Which of these possibilities resonates most deeply with your view of the cosmos? Was it the humble microbe following a quantum scent, or the tragic time traveler whose accident forged a new reality? Share your thoughts in the comments below, and if your curiosity for the universe's greatest mysteries is still burning, subscribe for more deep dives into the unknown.